Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in as we go through linear modeling. So today we're looking at linear relationships between two variables. So remember, a variable is just something that changes from question to question. We usually denote it with a prenumeral or a letter, and it can represent anything. The variable can represent distance, time, cost, number of people, something like that. Anything that changes from question to question, that's a variable. So in linear modeling, we need to know which is the independent and dependent variable. So we're going to be looking at relationships between two variables. One of them will be an independent variable, one will be a dependent variable. As the name suggests, the independent variable does not depend on the other variable. The dependent variable, or dv, does depend on the other variable. So it's just customary that we put the independent variable, we graph that on the x-axis, and we graph the dependent variable on the y-axis or the vertical axis, okay? So even though we're putting the IV on the x-axis, we won't necessarily call the variable x. We could call it t, y, n, whatever we want, okay? So the independent variable is always on the horizontal axis, the dependent variable is on the vertical axis. So as an example, I might want to examine the relationship between distance and time, how far I've travelled in a given time. So in this example, distance would be along the vertical axis because it is the dependent variable. If I'm looking at distance and time, distance depends on time. How far I've travelled does depend on how much time has elapsed. On the other hand, time doesn't depend on distance. Time will keep going away whether I'm travelling or not. So the independent variable usually does involve things like time or the number of people or something like that, whereas the dependent variable will be things like distance, cost, things like that. Okay, so another example, if I was looking, say, hiring a hall for a party, and I wanted to look at the relationship between the cost of the party and the number of people at the party, it is the cost that depends on the number of people, not the number of people depending on the cost, okay? So that's the difference between independent and dependent variable. We always put the IV on the horizontal axis and the dependent variable on the vertical axis. So what we want to do is we want to come up with a linear relationship between the IV and the dV. And what does it mean if the relationship's linear? So I've written the definition of what it means if the relationship between the IV and dV is linear. I've done that in red. So what it basically means is that every time you go across one along the x-axis, the horizontal axis, whatever that might actually mean, every time you go across one, you're always increasing or decreasing the dependent variable by the same amount. So if I was, say, looking at a graph between distance and time, so I know distance is along the vertical axis and that time is along the horizontal axis. What I'm saying is that each time, say, a second goes by, the same increase to distance happens. So that would mean, every second I might be traveling 5 meters, or every second I might be traveling 10 meters. Each second I am traveling the same distance. So there is the same increase to distance each time a second goes by. It wouldn't matter if the horizontal axis was in minutes. It'd be the same principle. Each minute that goes by, I travel the same distance. That's what linear relationship is. You have a constant increase or decrease with every increase to the x variable, in this case the independent variable. Okay, so that's what it means if the relationship is linear. Fortunately for you, we will only be looking at linear relationships. So when we're asked to come up with a linear relationship, What we want is a linear equation that links the independent variable and the dependent variable. And we've gone through heaps what a linear equation means. So let's look at an example where we're given some values for two variables and we'll make it into a linear relationship. So let's look at the table that I have here. So this table is representing, if I say go on a cruise, how much the cruise will cost with different numbers of nights that I stay on the cruise. So this column here means that if I go for one night on the cruise, it'll cost me $250. And if I go for 3 nights on the cruise, it'll cost me $430, and so on. So firstly, this is a linear relationship because each time I increase the number of nights by 2, so I stay for 2 longer nights, the same increase is happening to the other variable. It's actually going up by 180. So every additional 2 nights that I spend on the cruise costs me an extra $180. So because it is the same increase to the cost of the cruise each night, this relationship is linear. Now, please don't look at the table and think that the variable on the bottom must automatically be the y variable, the dependent variable that goes on the vertical axis, because that's not always the case. So let's have a think about this. Which depends on which? Does the cost of the cruise depend on the number of nights that have occurred, or does the number of nights depend on the cost of the cruise? So obviously, the nights are still going to happen whether or not you go on the cruise. The cost of the cruise depends on how many nights you stay on the cruise. So, of course, that would mean that the cost of the cruise is the dependent variable because it depends on the other variable, and the number of nights is the independent variable. Okay? So, if you like, think of the cost of the cruise as y and the number of nights as x. So, I want to come up with a relationship. I want to come up with an equation that links the value in the top row with its corresponding value in the bottom row. I want to find an equation that links these two values and these two and these two and these two and these two. So this isn't new to you. We've actually done this already. You know how to come up with linear equations when you're given points, and each of these columns is just a data point. You've got 5 points. So remember, we know that any linear relationship, and we know this is linear, can be written in the form y equals something times x plus something. That's true of any linear equation. We know that this is a linear equation because I just explained to you why the relationship here was linear. Okay, it wouldn't matter if I let y be c, c for cost, and x be n. It would be the same principle here. The y variable, the dependent variable, equals something times the independent variable plus something. So we know how to fill in these boxes. So this first box is the gradient. So remember how we figure out the gradient? The gradient is how much the dependent variable is increasing each time you increase the independent variable by 1. So we can use the 2-point formula here to find what number goes in there. So y2, this is m gradient, y2 minus y1 over x2 minus x1. Put it on your calculator, you should get the number 90. So that means the number 90 goes here, also goes here, because they're the exact same equation. So then we've got to figure out what goes here. So remember, what goes in that box is the value of the dependent variable, the y value, when the x value, the independent variable, equals 0. So you might be able to figure this out using logic. Because we're going up by 90 each time I increase the x variable by 1, I go up by 90. I could put another column here. If I go down by 1 in the x variable, I'll have to go down by 90 in the y variable. So it'll be 160. So that is going to go there. And again, the bottom equation is exactly the same. It doesn't matter whether you write it like this or like this. So I have just come up with a linear equation that links y, the cost of the cruise, with x, the number of nights. So the cost of the cruise is $90 for every night that you spend on the cruise, plus $160. That's probably a booking fee or something. So I can use that equation to find out the cost of the cruise for any number of nights. If I wanted to find out the cost of the cruise after, say, 12 nights, it would just be 90 times 12 plus 160, so that would be $1,240. Okay, so that's how you do it. There are a lot of extra words and terminologies that you have to learn here, but essentially it's what we've already been doing, finding the equation of a line given a few points. That's exactly what we're doing here. Okay, so if you were to graph this function, you already know how to graph. I'll just draw a rough sketch. So of course, if the x value or the number of nights is 0, then the cost is 160, and this will be like a linear function like that. So after, say, 3 nights, it will cost you 430. Okay, so it'll just be a straight line because it's a linear function. Alright, I hope you've enjoyed this video and got something out of it. This has been the luckiest maths teacher in the world. Have a great day.